The MixShield S880 tunnel boring machine, the largest TBM in the world, designed for extreme underground projects.
The simulations show high stress concentration here, near the main bearing seal.
Yes, the pressure chamber interaction.
Rotating the model to the backup gantries.
Okay, zoom in on that stress zone. The pressure differential is too high in this chamber.
We need to increase the structural strength for the underwater phase.
Agreed, but the current shield thickness affects the slurry pressure.
Switching to the wireframe view confirms the load path issue at the shield joint.
The optimization model shows a 20% reduction in localized stress.
This demonstrates the rotation path through the hardest strata.
What about the torque distribution here in the red zone? Can the segments handle that sustained pressure?
The pressure balance looks stable at 3.5 bar.
Yes, the slurry circulation is maintaining phase pressure against the seawater.
If we follow this sequence for the main bearing installation, we gain 2 days.
Let's cross-reference that with the updated.
The ultrasonic reading here is inconsistent. See the waveform deviation?
Yes, the X-ray confirms a sub...
Alignment confirmed on section 4. We have green across the board.
Looks good. Let's prep for the next segment.
This joint meets the S880 safety specifications.
Agreed. The X-ray confirms the integrity.
The massive pressure chamber of the MixShield S880. Thick steel components are assembled.
All right, easy now. Bring that segment down another 2 meters. Watch the clearance on the bolts.
The audio captures an industrial soundscape.
The alignment needs to be absolutely precise on this flange.
Agreed. We double-checked the specs this morning.
A little to the left, easy now.
Alignment confirmed. Go ahead and set it down.
Roger that. Start the bolts.
Bring the cutter headlines through the main channel and double-check the pressure controls.
Electrical power distribution systems are installed inside the MixShield S8880 tunnel boring machine.
System check complete. We have full visualization.
Excellent work. The S880 is ready.
Low power sequence active. Check synchronization.
Systems are synchronized across the board.
Excellent. Confirmed installation is correct.
We finally did it. The S880 is ready. It's magnificent.
Slow down, slow down.
We're almost perfectly aligned. Lock it in.
This modular design allows the TBM to advance while continuously supporting excavation, lining, and material transport.
Check the pressure on line 3. We are stabilizing the segments now.
Pressure is steady at 5 bar. Flow rate looks good.
Ensure the coupling is secured tightly.
Airflow looks stable on the monitor. We are good to proceed.
Pressure stabilizing at 4.2 bar.
Torque levels look good. We can increase the advance rate by 10%.
The SASAV is fully integrated. Electrical control and hydraulic color.
Slurry pressure steady across all sensors. The S880 is fully assembled and ready for transport.
We just need final sign-off on the hydraulics.
These markings indicate the primary lifting points for the transport frame.
Confirmed. I'll update the plan on the tablet now.
All right, lift her slowly, set her down gently next to segment 4.
This section here seems slightly off alignment according to the specs.
Control, we have a minor alignment issue on the cutter head section.
Lower it slowly. Watch the alignment pins. Easy now. All right, secure it.
How are the lasers looking?
Dead center, boss. We are good to go.
All clear down here. Thumbs up, ready for launch.
The first excavation cycle begins as SA tunnel boring machine outside the launch chamber.
Pressure levels are fluctuating at the face.
Adjusting the bentonite flow now. Keep a close eye on the visualization.
Excavated material flows through slurry pipes of the mix shield S880 tunnel boring machine towards separation plants. The segment erection process begins behind the cutter head of the mix shield S880.
These inserts are completely blunted. We have to replace this set now. I'm logging it. The replacements are ready at the next access point.
Watch the clearance on the left side. Easy.
It's seated. Start the tightening sequence.
Confirmed. Applying torque. The slurry pressure is spiking again. We need to stabilize the mix.
Check the torque limits on screen 12. I'm adjusting the advance rate now.
Check the pressure on regulator 7.
Looks stable. Keep monitoring the flow rate.
The pressure is spiking at the face. We need to increase the slurry density immediately to maintain stability.
Hydraulics check complete. Pressure is stable.
All right, let's move to the next section.
The deformation trend line is rising faster than projected right here.
Right. But the real-time settlement readings show we are still within safety.
Look at the pressure spike. We are hitting hard rock.
I see it. Ramping up the cutter head thrust immediately.
Check the pressure on the main bearing.
It's reading optimal, confirmed on the tablet.
After maintenance, the MixShield S880 tunnel boring machine resumes full-speed excavation. Performance metrics return to optimal levels.
The S880 is showing decreased efficiency in the shale layer.
Agreed. But if we reduce the rotation speed by 10%,
Main power secured.
Control, this is Supervisor. All personnel accounted for at muster point 1.
We hit the target depth, 88 meters.
Confirmed. Excellent work, everyone.
Maintain the slurry pressure at 0.6 bar.
Roger that. Pressure holding steady.
Ensure the seals are holding pressure. Seal integrity confirmed. Monitoring systems are online. Final reinforcement secured. We are clear for the push. We did it!
Yes, finally through.
Pressure holding steady across the board.
confirmed. The S880 is fully stable. Mission accomplished.
Well done, both of us.
We need to ensure these are marked clearly before we disconnect the hydraulics. Sequence is crucial here.
Understood. I'll double check the coupling torque now.
Crane operator, we are clear for the lift. Tension is good.
Roger that. Moving segment clear of the lining now.
The sequential dismantling clears the critical path, preparing the tunnel for the final lining and tracks.
All right, team, slow the approach.
We are 50 meters from the access shaft. Prepare for the vertical transfer sequence.
The alignment on this ring looks almost perfect.
Yes, the sealing is consistent too. The TBM is performing well.
Bring the next section forward. We need to secure the hangers now.
All right, I'm moving the lift into position.
The laser scan confirms the diameter is perfectly consistent here.
And the alignment looks spot on, well within tolerance.
All right, easy now. Bring it down slowly. Watch the clearance on the left. A little more to the right. Okay, hold it there.
The advance rate confirms the S8's success, well above target.
Fantastic.
However, these wear statistics highlight additions.
The diameter is holding perfectly at 11.998 meters, well within the 2 millimeter tolerance.
And the
From the factory floor to the final breakthrough, the MixShield S880 represents a triumph of modern engineering.
We need a bracket for the ventilation duct now.
Here, use this one. Secure it tightly before we move the lift.